Okay, so today I'm going to talk to you a little bit about ship traffic in Southern California, and there are some other people in the room that can probably speak a lot more about ships than me, being a graduate student down at Scripps Institute of Oceanography. But what I've been doing with my research is looking at ship noise in the marine environment, and because of that research, I've started to get to know ships a little bit better, and therefore I have some information on these ships, and I do like to do a lot of data analysis, so I've been able to look at some of these patterns. And this hasn't been alone. This has been an effort with Steve Katz from the sanctuary over there. I'm looking at processing some of this data. Chris Condit and Sean Walbridge helping with just the data processing and spatial analysis. And more recently, TJ Moore and Jessica Redfern at the Southwest Fisheries Science Center. So some of this talk is just going to set up what Jessica's going to talk about next. So for those of you not familiar with the data that I'm using for this is from the Automatic Identification System, known as AIS. This system is required on ships over 300 gross tons. And basically it was designed for vessel collision, for ship-to-ship communication, especially on the high seas, and traffic services within harbors, which Captain McKenna is part of at the Marine Exchange down in Long Beach. And it's essentially a radio signal. It's just a VHF signal that's transmitted from ship to ship, and you can, and this diagram is just showing you how those signals can move around from ship to ship, from shore station, and then disperse from those stations there. A lot of information that's transmitted through this. But one thing to keep in mind with this, and I'm going to bring up some points just working with this data, it wasn't designed for retrospective analysis. It was designed for safety at the height, safety between ships and ship-to-ship communication. So there's some things to remember about this data, and maybe some limitations or at least considerations you have to take into account when trying to do any sort of spatial analyses with this data. And so just to highlight a few of them that I've come across. Number one is the no timestamp. So when that signal is sent, at least in the data that I'm receiving, I'm not as familiar if there's differences with the Coast Guard data, but in the data that I've worked with, basically I've had to sync it with an internet time when it reaches the receiver. So you have a slight delay in time. It's not very much, especially if you're looking over short distances, but it's something to keep in mind when you're looking at that. Or if you get AIS data, knowing what the time was that it was stamped on that data before you can do any analysis with that. The other is there's a high temporal resolution, so you're getting a ton of data. There's ships transiting like every 30 seconds. So imagine if you have a whole bunch of ships out there. So it's a lot of data to kind of put together and process. And so we've come up with some ways to do that. And that's simply using this georeference database that's been helpful to go in and be able to query that data easily and then spatially represent that. And the last point there is this variable spatial resolution. Because you're dealing with radio signals, there's going to be transmission differences depending on where you're looking. You're going to have shadows from the islands, or you're just going to have certain atmospheric conditions that are going to influence what the signal you're receiving. There's a couple ways to deal with it. What we've done is we've either spatially limited the analysis that we're looking at, so we're fairly confident in that area. We've also more recently looked at connecting AIS points, so trying to account for some of those gaps in the data by creating individual ship tracks from this data, and I'll give you an example of that. So this is just showing you what, I don't know, it's like a 3-month period of just the AIS points on the top graph, and then going through these steps shown here, where you start with the points, you sort by ID and timestamp, and you kind of set some parameters around how you want to define the ship track. If it's the same ID and the time difference is less than 24 hours, well, let's connect those points. However, if the ID changes or the time change is greater than 1 hour and you have a big heading change in the ship, you probably don't want to connect those points because who knows what that ship might have done in that hour period. So you can start a new track. And so you can see from here we have, so the station, AIS station, the data that I'll be talking about today is from this point here. It's pretty good coverage in the channel, but you can see the shadows you get south. But once you connect those dots, you can get a better representation of the traffic south of the island. And again, this is just showing you that where we have AIS sites moved over time, and that's basically just either better receptions. We started in the Santa Barbara Harbor, but that really only got good coverage here east of the channel. Slowly moved it out to the University of California Santa Barbara campus, and moved 2 sites because there was better internet connection. And then recently we have this site out on San Clemente Island, and I'm not going to be talking about data from this site. And I'm just bringing it back to why I was collecting this data. This is where my acoustic instruments is sitting, and so that's where I'm matching the ship traffic data with acoustic data to learn more about the acoustics of these ships. So 2 things I'm going to address in the remainder of this presentation are looking at recent changes in vessel traffic and where are the major shipping routes. It's kind of relevant to when we start to overlay that with what's going on with the whales. And then this last part is work that I've done with Steve Katz. It's looking at compliance to a voluntary speed reduction. Now, this is an example that's here on the West Coast. I know Greg is familiar with lots of examples on the East Coast too, so I just wanted to give an example in the discussion later. We can talk more about why or not these do not work. So recent changes in ship traffic. Basically, most of us are familiar with the economic downturn, and this is a graph that I've taken that's just showing you loaded containers coming into port, and you can see that there's this dip in container traffic coming in, and these are outbound ships going out. So we have this overall decrease in ships in this area, and then we also had this California Air Resources Board rule. I know this picture is a little dramatic, but it brings home the point that this rule went into effect that was trying to improve the air quality along the California coast. And so essentially, they required ships within 24 miles of the coast to burn cleaner fuel. And so in response to this, as you'll see in the next couple of figures, ships changed their patterns. They didn't go the same routes they did before. Whether it was to avoid this 24-mile rule or whether there was problems with actually operating the ship on that cleaner fuel. So here's, so I've limited the data now just looking at cargo and tanker ship traffic in 2008 and 2009, and you can see where, in 2008, yes, they're sticking to those lanes pretty well. And this is a kind of cumulative kilometers traveled per grid cell. So this is telling you how many kilometers they were traveled. So most of them are traveling the shipping lanes. You do have some traffic south, and that's mostly the tankers. And then you see this dramatic change in 2009, where you have a lot of traffic here. However, if you look, which is a little small, but if you look at these scales here, there's a difference. You also have this drop in traffic. So this, I think, is about 700 is the greatest area of kilometers traveled, where this is only 200. So you've had not only this decrease in traffic, but also you've spaced out the traffic. So your overall count of kilometers traveled per grid cell is going to go down. And if you look at this total transect in the whole area, you have about a 20% decrease in shipping traffic based on this analysis. And if you look at that another way, you and kind of take those 2 years and you subtract what was the kilometers traveled in each cell, and you can say, okay, well, blue is showing you where it decreased the amount of kilometers traveled pretty significantly in some areas by more than 500 kilometers. And then even with this overall decrease in traffic, you've had this increase south of the channel, and this in the red and the oranges are showing you where that traffic increased. So even though there's this decrease overall, you're still having this increase south. And the point of this one is I wanted to, you've seen some of these other backdrops before, but what are the ships doing in this area? So I tried to pull up some individual tracks so you can kind of get an idea of how ships are moving through the area. There's the ships in the Santa Barbara Channel. They're nicely following the traffic separation scheme that's set up there. Then you have this traffic south of the islands, which kind of varies in terms of where they're going. I know this has been a concern for a safety side. There's been close calls with collisions, and I can see why there's a little bit of confusion there. I also wanted to point out two other ports in this area. There's a Port Hueneme, where you have traffic going in and out of Port Hueneme, which I think there's vehicle carriers going in and out of that port, and I think that's the majority of these ships that are going in there. There's also this off Redondo Beach. I guess it's not really a port, because they're kind of just these are tankers going into that area and offloading the oil there, because there's a refinery on land. So just to show you the diversity of tracks within the area. Keep in mind when Jessica gets up and presents next. Now I want to go into this voluntary speed reduction measure. And this gets back to what Monica brought up yesterday in 2007. There was this spike in ship strikes of blue whales, and this just shows you the timeline. So it was deemed an unusual mortality event because there was a lot of whales that were struck in a short amount of time on a small spatial scale, and that's just giving you the representation of that. And so in response to this, the Coast Guard and NIMS got together and said, well, what should we do about this? And one that they came up with is sending out these local notice to mariners. And this is a way for the Coast Guard to communicate with mariners in the area about updating them on certain safety hazards or information in the region. And so this notice was sent out, and it was basically in the Santa Barbara Channel and traffic separation zone. Do not exceed 10 knots. There's large whales, so it varied, and you can see there was two kind of versions. At first, it didn't have a specific speed reduction, and then it did have a 10-knot reduction after that. And this is based on the fact that research has been done. If you slow down a ship, the chances of fatality are going to decrease. So that's why you would want to decrease the speed of the ship. It was repeated in 2008 and 2009. I don't have the whale data, and after seeing Monica's presentation yesterday, I think can fill in some of these strikes. But as a precautionary approach, these local notices to mariners were sent out in 2008 and 2009. So this was the targeted management area shown here in mesh. There's the 2 shipping lanes and the traffic separation zone. And we just asked the question, did daily average speed in this region decrease in relation to these local notice to mariners? And on an individual basis, so are there ships that traveled before, during, and after these notices, and did we see a decrease on an individual basis? Before I go into those speeds, it's good to understand the variability that you're going to see in some of the data because, well, the majority of traffic is container ships, and so I've divided out those 2 types of ships because they travel just by the nature of their design, they travel at different speeds. But within cargo ship, there's a diversity within that cargo ship, which is important to point out. The container ships travel the fastest. You also have vehicle carriers, which travel at about 17 knots, and then bulk carriers that travel at about 15 knots. So there's a diversity within the category of cargo ships, so it's important to consider when you're looking at speeds. So this is just plotting some speeds in the area, and here's your scale bar over here, so purple is less than 12 knots, and these are during each of the local notice to mariners, and we're really focused in this region here. And so this isn't data where I've actually used the tracks to connect the points, so you can kind of ignore the data south. But a couple points that to make here is that you have some slowdown when ships are going in and out of port. You can see kind of goes to green there. And you also have this speeding up, so the higher the red color on the outside of the lanes, that are passing each other, so you get a diversity of speed within those lanes. You also have this inshore traffic here, which is mostly just the ships going to and from the oil rigs, carrying passengers or carrying goods out there. So they just travel at slower speeds between those. And then 2009, the same thing shows up again. You have increased traffic down here, faster ships, but you also see a decrease in the channel. And I think that's it's an interesting thing that's happening here. And just by looking at some of the data, although AIS doesn't give you that if it's a bulk carrier or a container ship, but it seems like the containers were the ships that decided to travel south, and the bulk carriers were the ones that stayed within the channel. For whatever reason that may be, I don't know, and maybe some folks can give insight on that. Now, if we look at tankers, they just tend to travel at 12, 14, or 12 to 16 knots. Most of the traffic is south of the islands, although you do have the traffic within the channel. And now this is taking those ship speeds and looking over time, and this is a 7-day running average. And you can see the different local notice to mariner periods, and you can see there's not really much of a change, although you see this dramatic drop in speed associated with the air quality rule happening right at that point. And then when we looked on an individual basis, this point here, we picked out 439 ships that traveled before, during, and after at least one of these notices in this time period, and only 3 reduced their average speed to below 11 knots in that subset of the data. So on a population-wide scale, compliance is pretty much undetectable based on that graph I just showed you, and at best, individual compliance was less than 1% based on the analyses of these studies. So it begs the question of, well, what was going on here? And I'm sure this can be part of the discussion today. I don't really need to get into it now, but some points to consider with why this might not have worked, and examples again on the East Coast that will shed light on this. They were not necessarily aware of it. They did not perceive a regulatory threat. There are a number of disincentives that might be out there. You're adding cost to their voyage. It's a large spatial area. You're asking them to slow down in. The fact that there's no incentives for them to do it, and potentially a scale mismatch. These ships are coming on voyages across the whole ocean, and you're asking them to change their behavior in a small spatial area, so therefore they might not have accounted for it in their journey. Maybe if they knew about it when they were on the other side of the ocean, they could account for it in their journey as they entered the Santa Barbara Channel. And so just in summary, to set up Jessica, diversity of traffic in the area, just tried to point out that there's lots of movement. There's this response to the carb rule, which is evident in the AIS data, and then this limited compliance with the vessel